I'm Shalini V, working as Assistant Professor of Physics. In this video, I will discuss the topic for the session 34 of first semester B.Sc. The topic of this session is origin of elastic forces. So before discussing the topic, we have to know what is elasticity, what are perfectly elastic bodies, and what are perfectly plastic bodies. Elasticity is the property of a material body to regain its original condition on the removal of the deforming forces. Then the bodies which can recover completely their original condition on the removal of the deforming forces are called as perfectly elastic bodies, and the bodies which do not show any tendency to recover their original condition are called as perfectly plastic bodies. There are no perfectly elastic or plastic bodies are there. The nearest approach to a perfectly elastic body is quartz fiber. Then the origin of elastic forces. So the property of the elasticity of the bodies can be explained on the basis of the interatomic forces existing between the two constituent particles. So if we consider an each atom it has a positively charged nucleus and a negatively charged electron cloud. Thus each electron cloud it will experience an attractive force due to the other nucleus and a repulsive force due to the other electron cloud. In addition to this one, the two nuclei will experience a repulsive force. Then the resultant of all these forces, either attractive or a repulsive, but at equilibrium condition it will be zero, that is at a separation of r naught distance at that particular point, that is at equilibrium, resultant of either attractive or repulsive forces will be equal to zero. The magnitude of the attractive or repulsive forces, it depends upon the distance between the two atoms and will be effective only within a few atomic distances. Now consider the variation of the attractive and repulsive forces with the separation between the atoms. So for the figure A, first figure represent the variation of the attractive forces between the atomic separation. And the second figure, that is a figure B, represent the variation of the repulsive force with the atomic separation. Then the third figure, that is figures 3, represent the variation of the resultant of both attractive and repulsive forces with the atomic separation. So from figure A and B, it is clear that the repulsive force it increases rapidly than the attractive forces for the distances less than the equilibrium distance or not, where at the particular point the overlapping of the electron cloud starts. Then the third curve, it is obtained by superposing the both the curves A and B. So at the equilibrium distance, that is at the distance of separation equal to R naught, the resultant force will be equal to 0, or the attractive force is just balanced by the repulsive force. At that particular distance, that is at the distance less than R naught, the resultant force will be repulsive, and at a distance greater than the R naught, the force will be an attractive force. So suppose if an external deforming force acts on a system of two atoms, then it produces a change in the interatomic distances. So there will be a change in the interatomic distances from M to N or from M to L, and an internal force AN or BL comes into play, which counteracts the deforming force. The force here, the force AN and BL, it represents the stress. The change in interatomic distance, that is from Mn or Ml, it represents the strain, whereas the An and Bl represent the stress. As long as internal stress developed lies within the linear region of xy of the curve, the stress will be proportional to the strain, which is nothing but the Hooke's law. So this is the origin for the elastic forces. So this is the book which I have referred for this topic, College Physics Volume 1 by N. Sundarajan, George Thomas and Syed Azeez. Thank you.